Hello everyone, this is Vijay Lakshmi Sugnani from WinMaths YouTube channel. WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation well for exams. Okay, now in this session we have to discuss the concept, relations and function. In last session we already discussed the definitions of relations and functions already. We saw some example based on the function. Next, continue the session. Here there is a exercise 1.2. Okay. First question, show that the function f from r tends to r, that is real number tends to real number defined by a function f of x is equal to 1 by x is 1 1 and onto, where r star is the set of all non-zero real numbers. So here r star indicates the non-zero real numbers. Is the result true if the domain r star is replaced by n with codomain being same as r? Okay, here there are two conditions. We have to check the condition, that is f of x is equal to 1 by x for the function f from real number to real number, as well as again we have to check the result for domain will be same. Then we have to replace codomain by the natural number for second condition. Okay, so I will take the first condition. The function r star tends to r star. Here r star be the set of all the non-zero real numbers defined by a function f of x is equal to 1 by x. Okay, we have to check the function whether it is 1 1 or onto. Okay, according to the definition of 1 1 function, if a function f from x tends to y, every element of domain, that is has the distinct element has a distinct image in codomain. Okay, that is f of x1 is equal to f of x2, then x1 is equal to x2 for every x1 x2 belongs to the set of non-zero real numbers. Okay, this is the definition. Now I apply the definition here. For f of x1, replace x by x1, so x1 f of x1 is equal to f of x2. What is the x1? Here according to the definition, f of x is equal to 1 by x. I replace 1 by x1 is equal to 1 by x2. Okay, then take the cross multiplication. X2 is equal to x1, or else I can return x1 is equal to x2 for every element of x1 x2 belongs to the real number, that is non-zero real number. If I can take the x is equal to 0, then function will be not defined. That's why I can take the set of all non-zero real numbers. Okay, now again I will check the condition for onto. Here this is 1 1 function condition, then check for onto. According to the function, that is f of x is equal to y. So what is the f of x? 1 by x is equal to y. Then I want the value of x, that is equal to 1 by y. 1 by y is the real number? Yes, it is real number, but we can take the y value except 0. If I can take the y is equal to 0, then the function not be defined. Therefore, for any domain or codomain, okay, here x be an element which is belong to real number except 0, and the image y belongs to r star except 0. Okay, therefore for these two conditions, the given function will be 1 1 and onto. The given function is 1 1 and onto. Okay, now again the first condition is over. Now I will check for the second condition, just replacing the function r tends to n. Here codomain replaced by the natural number. Okay, Let us consider the function f from r star tends to natural number. Okay, here checking the condition 1 1. Let by the definition of 1 1 function, every distinct element in a domain has a distinct element in codomain. That's why take f of x1 is equal to f of x2. Okay, what is f of x1? That is 1 by x1 is equal to 1 by x2. Then taking cross multiplication, x2 is equal to x1. I can rewrite here, that is x1 is equal to x2 for every x1, x2 belongs to R. Okay. Similarly, I will check for onto condition. Okay. By the definition of onto function, f of x is equal to y, then we have to find the value of x. That is, then replace f of x by 1 by x is equal to y. So y is equal to 1 by x. 1 by x is not a natural number. Okay. Natural 1 by x is not a natural number. So the given function does not holds the onto condition. Therefore, the given function does not holds onto condition. And finally, a function r star tends to n holds only 1 1 condition. 1 1 function or 1 1 condition. This is the solution of the given problem. Okay, let us move on the next question. Question number 2. Check the injectivity and subjectivity of the following function. Here there are 5 functions are there. Based on the 5 functions, we have to check the injectivity, subjectivity. Here injectivity, subjectivity means already we know that injectivity means 1 1 function, then subjectivity means onto function. So for these two functions, we have to check the 1 1 and onto condition. Okay, just I will plot a ray diagram for this, then you will have a clear picture on the concept. Okay, here first generally I will take the row diagram here. The set A containing here function from natural number to natural number. So I will take the natural number set. Here also natural number set. Already we know that the natural numbers always starts from the 1. So I can write here 1, 2, 3, 4, 5 up to so on for infinity. The number starts with 1 and up to infinity are called the natural numbers. Here also from the natural number to natural number. 1, 2, 3, 4, 5, 6 up to so on. Okay. So now I will apply the function f of x is equal to x square. Okay. When I substitute x is equal to 1, then 1 square will be 1 only. Okay. Then x is equal to 2. Here, what is the value of f of x? Here, this is f of x 4. Then x is equal to 3. Then f of x will be 9. The first 1 is related with 1, 2 is related with 4, 3 is related with 9 up to so. Okay. So every element of domain has a image in natural number set. Okay. Then 1 1 function holds, but onto condition. Okay. 2. 2 does not contain any free image in domain. 3 also does not contain free image in domain. That's why onto function not holds here. Okay. Just by the draw the ray diagram. So I will write here by the definition. Let's consider first 1 1 function. According to the 1 1 function, f of x1 is equal to f of x2. Okay. So f of x is equal to x1 square is equal to x2 square. Taking square root on both sides, it becomes x1 is equal to square root of x2 whole square becomes plus or minus x2. Or else I can write x1 is equal to plus x2, or else another one definition, x is equal to, that is x1 is equal to minus x2. Now here I can consider only the one condition, that is x1 is equal to x2, because always the natural number starts with 1. It means the natural number always positive numbers only. Natural number does not contain any minus or else any negative value. So the condition we have not considered. Therefore, x1 is equal to x2 for every x1 and x2 are belongs to natural number. Therefore, 1 condition satisfied. 1 satisfied. Similarly, I will check the onto condition. That is f of x is equal to y. Substitute f of x here, that is x square is equal to y. Then what is the value of x is equal to, taking square on right side, it becomes square root of y. But square root of y not a natural number. Okay. Therefore, onto condition not satisfied. That is, this is not onto for natural number. By the definition as well as by arrow diagram, what we conclude, a function f from natural number to natural number given by f of x is equals to x square is only 1 but not onto. Okay. Now, similarly, check for the second condition. The function f from z tends to z given by the f of x is equal to x square. The function should be same, but domain and codomains are changed here. Just replace natural number to natural number by integers to integers. Okay. I will write here. Okay. Again, I will consider the ray diagram. This is 1 but not a onto. Okay. Now for second condition, I will take f of x is equal to x square, the domain, a function from integer to integer. We already know that integer means the numbers having positive, negative, including 0. The numbers are positive, negative, and including 0. So domain and codomain will be the integers. I will take the ray diagram here. Okay. Then z tends to z. 0, -1, -2, -3. Here plus 1, 2, 3 up to so on. Here also up to so on. 0, -1, -2, -3 up to so on. 1, 2, 3, 4 up to so on. Okay. Now I consider here by the definition f of x is equal to x square. Now I substitute x is equal to 1. Then the f of x should be 1 square is 1. 1 is related with 1. Again, I substitute x is equal to -1. Then -1 whole square. -1 whole square will be +1 only. Okay. So -1 is related with 1. Then f of 0. X is equal to 0. 0 is related to 0. Similarly, whatever the values, we have to take positive and negative values holds this image. Okay. So it is not a 1 as well as onto. Not 1 not onto, because distinct, according to the definition, distinct element have a distinct image in codomain. But here the distinct, two distinct elements having the same image. This is not the definition of 1 condition. Okay. So I will return here theoretically, that is f of x1 is equal to f of x2. Okay. What is the x1? x1 square, x2 square. Okay, taking square root on both sides, then it becomes x1 is equal to plus or minus x2. So I can write x1 is equal to plus x2 or x1 is equal to minus x2. Here, x1 has the two images. By this definition, the distinct element have a distinct image in domain as well as code. By the definition, it is not always. So, 1 1 not satisfied. 1 1 not satisfied. Similarly for onto condition. Okay. Similarly for onto condition. F of x is equal to y. Okay. F of x is equal to y. Then what is f of x? That is x square is equal to y. Y is equal to x square. We want the value of x is equal to root y. Okay. Root y is not belongs to the integer. Okay. Root y is not a element of integer. So it is not onto. Therefore, it is not onto. Hence, the given function is not 1 1, not onto. Or we can write the given function f from z tends to z is given by f of x is equal to x square is neither 1 1 nor onto. Okay, let us consider the third condition. A function f from real number to real number is given by f of x is equal to x square. Okay, here the function f from real number to real number f of x is equal to x square. Okay, now I will apply the definition here. According to the definition, f of x1 is equal to f of x2 for 1 1 condition. So I will check the 1 1 condition here. F of x1 is equal to f of x2, that is x1 square is equal to x square. Okay, while applying the square root on both sides, then we will get the result x1 is equal to plus or minus x2, that is x1 is equal to plus x2, or we can get x1 is equal to minus x2 for the same image does not containing different, or else the different elements having the same image, then it is not a 1 1 condition. Okay, according to the definition of 1 1 condition, distinct element have a distinct image, but here distinct elements having the same image, that's why 1 1 condition not satisfied. Okay, it is not 1 1. Similarly, I will check for onto condition. Okay, that is f of x is equal to y. While substituting f of x is equal to x square is equal to y, then y is equal to x square. That is y is equal to x square. We have to solve for x, that's why x is equal to root of y. Root of y belongs to the rational number s. Root of y belongs to the rational number y. But here, for negative values of y, for negative values of y, it holds the complex number, or else it becomes imaginary. It holds the imaginary number. That is, it holds the Im- imaginary. That is, x is equal to root of minus y. X is equal to root of minus y, not a real number, because it is a imaginary number. That's why the function f of x not onto. Therefore, what we written, the given condition for a function f from R tends to R given by f of x is equal to x square is neither 1 1 nor onto. Neither 1 1 nor onto. Okay. Then the third condition over. Again, we have to check for the fourth condition. A function f from natural number n to n given by f of x is equal to x cube. Okay, we have to check the fourth condition for f of x is equal to x cube. I will check here. Okay, take a screenshot of the solution. Now, okay, here I will take the result here. So for the fourth condition, that is a function n tends to n given by f of x is equal to x cube. Okay, according to the definition of one condition. According to the definition of one condition, we have to take the values. Okay, here f of x is equal to x cube, f of x1 is equal to f of x2. Then x cube is equal to x1 cube equal to x2 cube. Then the value becomes x1 is equal to x cube. While taking the cube root on both sides, we get the same value because while taking the example. So 1 cube becomes 1 only. Similarly, for example, whatever the value we have taken for negative values, we will get the negative value. Then for cube root of positive value, get the positive value only. That's why the given function is 1. Distinct element having the distinct image in coordinate. The function is 1. Similarly, for onto condition, let f of x is equal to 1. So what is the value of f of x? X cube is equal to y. Then solve for x, that is y, cube root of y. So x to the power y to the 1 by 3. Okay. So y to the power 1 by 3 is not a natural number. It means every codomain does not have a pre-image in domain. Every codomain does not have any pre-image in domain. That's why the onto condition does not obeys here. Therefore, f is not onto. F is not onto. Therefore, the given function n tends to n given by f of x is equal to x cube. For this condition, the function is 1, 1, but not onto. Okay, but not onto. Now, you have to solve for the fifth condition, that is a function f from integer to integer given by f of x is equal to x cube. Okay. Now, this is homework and you have to solve. If you have any doubt regarding the fifth question, just write your doubt on a comment box. Okay. Then move on the third one question. Prove that the greatest integer function f from real number to real number given by f of x is equal to greatest integer of x is neither 1 nor onto. Okay, where x denotes the greatest integer less than or is equal to x. Okay, that is we have to check for the greatest integer function. Now let us consider the given function f from real number to real number. The function f of x is equal to greatest integer of x. According to the definition of the greatest integer function, whatever the values we have taken, for example, f of 1 can be written as greatest integer of 1. Then f of 1.6, then it is also 1. Whatever the values we have taken from 0 is less than to x less than 1 or less than or is equal to 1, then it holds the value. Okay, whatever the x value we have taken here in between the 0 to 1. Okay, so the values holds to 1. By this definition, we have to check the greatest integer function for 1, 1 as well as onto condition. Then we have to prove that the function does not containing 1, 1 as well as onto condition. Okay, so according to the definition of 1, 1, Okay, according to the definition, first we have to check for 1. Okay, let us consider f of x1 is equal to f of x2. Here, f of x1 can be written as greatest function of x. Here also, greatest integer function of x2. Okay, x1 distinct element is equal to greatest integer of x2. So I can take x1 is equal to x2 for every x1, x2 belongs to the real number. Okay, here 1.6. Taking the example, here 1.6 does not equal to 1.7 because while taking the greatest integer of 1.6 and 1.7 is equal to 1, but usually 1.6 and 1.7 are not equal. While taking the greatest integer, it becomes equal. So, distinct element having the same meaning. So, while taking the ray diagram here, okay, 1, 2. Here in between 1.2, 1.3, I have taken the real number here 0, minus 1, up to so on. Similarly for 0, 1, minus 1.2, 1.3. These are the plus up to so on. Here minus 1, minus 2, minus 3. The greatest integer of 1.2 indicates the 1. So 1.8 related with 1. So distinct elements having the same image in code. Distinct having the images having the codomain in real number, that is codomain. Therefore, distinct elements distinct elements having distinct elements having same image. That's why it is not a 1. Okay. Similarly, for onto condition. Okay. Similarly, for onto condition, f of x is equal to 1. So the greatest function of x is equal to 1. So every okay, every images have a free images in domain. According to the definition of onto function, every image have a one and only free image in domain. But here the same image having more than 2 or more than 3 images, that is free images in real number. That's why every image has more than one image. Every image has more than one image in more than one image in domain R. That's why F is not on. Okay, therefore F is neither 1 nor on. Neither 1 nor on. Okay, this is the proof of the given problem. Let us move on the next question. Question number 4. Show that the modulus function f from r tends to r given by f of x is equal to modulus of x is neither 1 nor onto. Okay. Now we have to check for the condition, or else we have to prove the condition. The given function is neither 1 nor onto for the modulus function. Okay. Now first I have to consider the definition, or else here the function f from r tends to r by given f of x is equal to modulus of x. Okay. Now, the function is neither 1 nor onto. If x is positive or 0 and modulus of x is negative if x is negative. Okay. So, I can rewrite the function f of x is equal to minus x if x is less than 0. X if x is greater than or is equal to 0. Okay. So, if x is positive or 0, when x is greater than or is equal to, the value becomes positive. If modulus of x is negative, that is minus x if x is less than 0. The condition is O. Now, we have to check the 1 as well as onto condition here. First one, let f of x is equal to modulus of x. Okay. So f of x1 is equal to f of x2. What is the f of x1? I will take modulus of x is equal to modulus of x2. While taking the modulus function for positive values, I will take the positive values. That is x1 is equal to x2. Okay. While taking the positive values, the answer we get answer positive number. Okay. Again, if I take a negative values, then the function becomes negative. Here, the values, whatever the values we have taken x, then the value becomes 0. Okay. Whatever the values we have taken positive, then we get the positive. Sometimes, but x1 and x2 are not a distinct elements. Okay. f1 and x2 are not a distinct element. Here for every real number to real number. So then we get the same number. Okay. That's why it is not a for every x1, x2 not belongs to the real. x1 and x2 are not belongs to the real number. That's why it is not a 1. Okay. Then for onto condition. Okay. f of x is equal to modulus of 1. Okay. F of x is equal to modulus of x. Then solve for x. If whatever the value of images, okay, it may be positive or it may be negative. The y value should be depends. Always the free image depends on the x. That's why it is not a onto. Okay, it is not onto. Therefore, by the definition of modulus function, it does not hold the condition. By definition of modulus function, the function does not hold the condition. Does not holds the conditions of does not hold the condition of 1 and onto. Therefore, the modulus function, that is f of x is equal to mod of x, is neither 1 nor onto. Neither 1 nor onto. Okay. This is the proof of the given problem. Okay. Now let us move on the next question. Question number 5. Show that the signal function f from r tends to r given by f of x is equal to 1 if x is greater than 0. Okay. F of x is equal to 0 if x is equal to 0. Then f of x is equal to minus 1 if x is less than 0. Is neither 1 nor onto. Okay. We have to prove that the signal function does not holds the condition of 1 as well as onto function. Now, simply I draw the ray diagrams here. Okay. So, real number to real number, the relations or its function exist. So, I will take 0, minus 1, minus 2, minus 3 up to so on. Then 1, 2, 3 up to so on. Here also in general I am taking the values minus 1, minus 2, minus 3. 1, 2, 3. Okay. The values f of x is equal to 0. Okay. X is equal to 0, then the f of x becomes 0. Again, x is equal to 1. The value of it becomes x is equal to 1 means always greater than 0. So it related to 1. If x is equal to 2, so it is also greater than 0. So the image will be 1. X is equal to 3. Then the image. Okay. Whatever the values we have taken as a images or elements in a domain, it holds the only one element. The range becomes 1. Therefore, okay, 1 also holds the related to 1, 2 related to 1, 3 is related to 1. According to the definition of 1 condition, distinct have elements having a distinct image. But here, say distinct elements having the same image. That's why 1 condition not holds. Is it clear? Similarly, for checking the onto condition, just observe the ray diagrams here. For the image 1 having the same free images 1, 2, 3, and image 1 has a different free images. Okay, then the real number 2 doesn't have any image or else doesn't have any domain in R, and also 3 doesn't have a free image in the domain R. Therefore, onto condition not satisfied here. Okay, now we have to write the according to the definition we have to prove the signal function is neither 1 nor onto. Okay, now let us consider a function f from R tends to R. Okay, so f of x is equal to the values. Okay, f of x is equal to the values 1 if x is greater than 0, 0 if x is equal to 0, and minus 1 if x less than 0. Okay, now according to the definition, f of x1 is equal to f of x2. Okay, f of x1 is equal to, I will take x1 and here also x2. Then by ray diagram, by ray diagram, what can I written? F of 1, f of 2 is equal to 1. Okay, whatever the values we have taken greater than x, f of 1, f of 2 is equal to 1. Therefore, distinct elements having distinct elements having same image, distinct elements having same image in codomain. Therefore, it is not 1. Okay, that again for onto condition. Okay, I can take for onto condition. Here, let f of x is equal to y. Then f of x I'm taking as a x is equal to y. So here y belongs to real number, but every codomain, codomain, every codomain does not have a proper pre-image, does not have a proper pre-image in domain. Okay, does not have a proper pre-image, and some of the element does not containing any free image in domain. That's why the function, therefore the signal function neither 1 1 nor on 2. Neither 1 1 nor on 2. Some of the examples or some of the questions have to take by doing the example. Then you will get the proper solution. Therefore, this is the proof of the given question. Okay. Now, let us move on the next question. Question number 6. Let A is equal to set containing the elements 1, 2, 3 and B be a set containing the element 4, 5, 6, 7. And the function they given in the order pair 1 is related to 4, 2 is related to 5, 3 is related to 6. Be a function from A to B. Show that f is 1. Here simply we have to show that the given function is 1. Okay. Just I will take the order player in a ray diagrams. Okay. Here the function f from A tends to B. So the ray diagram represents here. Okay. This is A is related to B. There exists a function f. Okay. A set containing the elements 1, 2, 3. B containing 4, 5, 6, 7. So 1 is related to 4, 2 is related to 5, 3 is related to 6. Okay. So while observing the ray diagram, every element of A has a image in B. Okay. Every element of A has image in B. That's why the condition 1, 1 is always. That is f of 1 is equal to 4, f of 2 is equal to 5, f of 3 is equal to 6. So I can write every element or every elements of A is related with distinct element of distinct elements of B. Okay, therefore, this is the definition of 1 1 function. Therefore, f is 1. Okay, just have to write every element of A is related with distinct element of B. Okay, then the given function is 1. This is the proof of the given question. Next, let us move on the next question, question number 7. In each of the following cases, state whether the function is 1, 1, onto or bijective. Okay, if a function is said to be a 1, 1, onto, then it is called as a bijective. Okay, so we have to check the first condition. F from real number to real number. F of x is equal to 3 minus 4x. Okay, so I will take here for real number to real number. But now I will check the condition for 1. Okay, according to the definition of 1, 1 condition, check f of x1 is equal to f of x2. Okay, so x1 is equal to 3 minus 4, x1 is equal to 3 minus 4 x2. First neglect the 3, 3. Okay, here minus 4 x1 is equal to minus 4 x2. This minus 4 get cancelled. X1 is equal to x2 for every x1, x2 belongs to the real number. Therefore, 1, 1 condition satisfied. 1, 1 condition is satisfied. Then again check for onto condition. For solving the onto condition, f of x is equal to 1. Substitute f of x is 3 minus 4x is equal to 1. Okay, so here I will solve for x. That's why taking y on right side, minus 4x is equal to y minus 3. So again x is equal to, taking minus 4 on this side, it becomes y minus 3 divided by minus 4. Okay, while taking the minus 4 multiply on whole equation, then it becomes x is equal to, taking minus common on the y minus 3, it becomes 3 minus y divided by 4. So 3 minus y divided by 4 is also a rational number. Okay, whatever the value we have taken. Y is equal to 1. 3 minus 1, that becomes 2. 2 by 4, that is 1 by 2 is again rational number. Whatever the values we have taken as a y, then you will get the same number, that is rational number. Therefore, it is onto. Therefore, it is onto. By the one and onto condition, the given function f of x is equal to 3 minus 4x is 1 as well as onto. If both conditions are obeyed, then the function is bijective. Okay, this is the solution of the given problem. Now again I will take the second question here. That is a function f from real number to real number defined by f of x is equal to 1 plus x square. Okay, 1 plus x square. Now I will check the one by one here. First, one condition. F of x1 is equal to f of x2. What is the f of x1? 1 plus x1 square. Here, 1 plus x2 square. So 1 get cancelled. x1 square is equal to x2 square. So x1 is equal to plus x2, or else x1 is equal to minus x2. According to the definition of one condition, distinct element having a distinct image. But here, distinct elements have a same image. Distinct elements have a same image. That's why it is not a one. It is not one. Clear? Again, I will check for onto condition. F of x is equal to 1. What is f of x? That is 1 plus x square is equal to y. So x square is equal to y minus 1. X is equal to root of y minus 1. Root of y minus 1 is not a real one, because whatever the values we have taken as a negative values. Okay, the negative values of y holds the complex number, because the negative values of y holds the negative values of y holds the property complex number of complex number or imaginary. So it is not a real number. It is not a real number, or else a real valued function. Therefore, f is not onto. That's why the given function neither 1 nor onto. Neither 1 nor on. Okay, this is the solution of the second condition. Now let us move on the next question. Question number 8. Let a and b be sets. Show that the function a cross b tends to b cross a, such that the function a tends to b is equal to b comma a is a bijective function. Okay, this is the theory based question. You have to solve this. Okay, this is the homework for you all. Okay, Up to this much, I have completed some exercise problems on 1.2. Still, some remaining questions are there. I will discuss in next session. If you have any doubt regarding this session, please write your doubt on comment box. And if you really like my classes, please like, share, and comment on my classes. Thank you. Thank you for watching my class.